So welcome to the new video on our damage mechanism series. Today we are going to talk about soil corrosion. Now soil corrosion is generally going to be a big factor when we are talking about tank bottoms, because tank bottoms are generally be subjected to soil corrosion because they are going to be in contact with the soil. Obviously this kind of damage mechanism would also be a considerable factor when you are talking about underground pipings, or where any equipment which is subjected to soil, it is in contact with the soil, or if it's underground, all of this soil corrosion can happen. So description of damage: the corrosion of metals from the exposure to soils are referred to as soil corrosion. Affected materials are carbon steel, cast iron and ductile iron. Critical factors: the severity of the soil corrosion is determined by multiple factors including operating temperature, moisture, oxygen availability, soil resistivity, soil type, homogeneity, cathodic protection, stray current drainage, coating type, age and condition. So multiple things have to be considered when you're talking about soil corrosion. There is no single parameter that can help you to determine the soil corrosivity. Instead, a number of characteristics must be seen. Soil resistivity is one thing. So we have already talked about this in various codes. We have said that the more resistive the soil is, the less amount of corrosion it is going to do. The less resistive the soil is, the corrosion rate is going to be much more accelerated. So soil resistivity testing is frequently used to estimate soil corrosivity, mainly because it is easier to measure. However, it can produce a wide variable results within the single refinery site. Soils having high moisture content, high dissolved salt concentrations and high acidity are usually most corrosive. Soil to air interfaces are often much more susceptible to corrosion than the rest of the structure because of moisture and oxygen availability. Corrosion rates increase with increasing metal temperature, and other factors that affect soil corrosion are galvanic corrosion, dissimilar soils, stray currents, differential aeration corrosion cells and microbiology induced damage. Affected units or equipment: underground piping and the equipment as well as buried tanks and bottom of the above ground storage tanks are going to be very much subjected to this. Ground metal support structures: piping running close to the ground under which soil has accumulated over the years to the point of reaching in contact or partially covering the pipe. Piping exiting the road or other crossing where soil has sloughed off or and is laying on or covering the pipe. Appearance or morphology: so it will generally be localized thinning. Okay, so soil corrosion appear as external thinning when the roughened surface and localized deeper attack or pitting. Poor condition of the protective coating is a telltale sign of the potential corrosion damage. Soil corrosion can be highly variable along an unprotected buried piping or unprotected underside of the storage tank bottom. Prevention and mitigation: so you can do two things. You can apply good coating and you can make sure that your coating has no issues. Obviously still you will have to excavate the pipe and you will have to check everything. Or you can go on and try to do a cathodic protection system, depending on what kind of cathodic protection you need. So soil corrosion of a carbon steel can be minimized by use of appropriate coatings and cathodic protection along with the special backfill to prevent the rock damage to the coating. The most effective protection is a combination of corrosion resistant coating and cathodic protection system. Inspection and monitoring: following techniques can be used for inspecting buried pipe or on-grade metallical components that may have become covered by shifting the soil as well as soil to air interfaces. Above ground visual survey can identify leaks coming to the surface of the soil. Smart picking devices employing UT or MFL can be used where piping is designed to send and receive the pigs or accommodate tethered pigs that can be sent through the line. So pigs are basically devices that can move forward and backwards. You can push them, you can take them back. A close potential survey on the cathodic protected line may be used to verify that the buried piping has a protective potential throughout its length. APFI 70 provides you on the basis of how to conduct this survey. Piping coating holiday survey can be done. VT of the pipe can be done after excavation. Guided wave examination can also be done, and pressure testing can also be done, but it will not tell you how much the corrosion has happened, but it will tell you if the corrosion is that much that it will facilitate leaking, or if your pipe is able to sustain the pressure that it is designed for. So it is something like this. So in this area you are able to see the corrosion that is happening. In this area you can see localized thinning. It has been excavated after 3 years of service, so it's something like this. This is the original thickness and this is the degradation that is happening due to soil. And that's it. In the next video we'll be talking about some other damage mechanism for a damage mechanism series. This is it for this video. Thank you.